I will present the third application named Simple Real-Time Sonar with the DSP56824, and I will ask my colleagues Daniel Brosteanu and Lucian Muntean to go into further details with this application. Please.
The general architecture of proposed system consists of three main parts: the emitter-receiver platform, the Motorola DSP56824 evaluation module, and the host computer. The emitter-receiver platform has the main task of conditioning the sonar signals. As active sonar system, it features both the acoustic wave source and the receptor, assembled together on the platform. Those two transducers are selected as a pair of ultrasonic sensor with similar electroacoustic properties. They define the sonar working frequency as 40 kHz. The electronic amplifier driver circuits of the ultrasound transducer, as well as the analog to digital conversion logic for proper receiving the incoming echo signal, are another important component of the platform, being assembled in close proximity to the sensors. The Motorola DSP56824 based evaluation module is the core unit of the sonar system. It is directly connected to the emitted received platform as well as to the host computer. All the sonar specific data processing operation, like the emitted wave sample generation, received signal filtering, target distance calculation, and so on, as well as the emitted receiving platform control and the data communication routines for sonar, are performed by the DSP. The host computer provides the graphical user interface of the sonar, simulating the real-life radar and the sonar scope. Now, I'll ask my colleague to perform a practical demonstration.
I will show some experiments to demonstrate the sonar operation. For the first demonstration, I will use a relatively large surface target positioned at around 1 meter distance from the sonar. As a result, the detected target with its corresponding distance are shown on the computer display. You can see some detection errors during the real-time operation of the sonar because of the very high directivity of the ultrasound waves. For the second experiment, I will use a smaller surface target positioned at about 60 centimeters from the sonar sensors. First, the DSP enters the initialization phase to configure the serial communication interface, serial peripheral interface port, at its maximum speed, 115 kilobits per second, as the data link with the host computer, as well as the communication lines with the emitter-receiver platform, through the on-chip port B as general-purpose input-output signals. Next, the DSP generates a 40-period rectangular shaped signal at 40 kHz to be sent to the transducer interface through the general-purpose input-output lines. To receive the echo signal from the target, the DSP commands the analog to digital converter on the transducer interface for input signal sampling and acquisition at 108 kilosamples per second. Then, it reads 2 kilosamples from the ADC into the received data buffer. The received data in the buffer is further processed by applying a digital low-pass filter, a 20 coefficient moving average filter, a threshold to avoid display in absence of a target, and finally, by calculating the position of the maximum value sample, all resulting in the distance to the target. As a last step of iteration, the DSP communicates to host computer the polar coordinates of the detected target as its distance and angle.
This application will be further used to build a self-guided mini robot able to move autonomously on a predefined route and to avoid obstacles on its way.